Hi children, in our previous session I explained about one of the important law related with fluids, that is Pascal's law, right? And now in this session I would like to explain one of the important phenomenon related with fluids, that is this phenomenon also related with our day-to-day life. You might have experienced that the ink dropped in your notebook can be blotted by using a chalk piece, right? And another experience we can say is during the rainy season you might have seen dampness on the walls, and also a cotton handkerchief we use to wipe the sweat, and it can blot the sweat. And these all phenomenon, how it is possible, how all this is possible, that is what I am going to explain today. Okay, so watch the video carefully, and here you can see pictures I have drawn here in the paper, and here I have drawn here two beakers. Okay, in both the beakers I have taken two different liquids. In one beaker I have taken water and in the other mercury, and both the beakers immersed very narrow glass tubes, and two narrow glass tubes are immersed in each of those beakers. And here what you can observe is, in the case of water, you can see the surface of this water taken in the beaker is curved inwards a little. And the other thing you can observe here is the water is raised through the tube. Isn't it? The raised up in the tube, and the level of this water raised in the tube is more than the level of water in the beaker. So note down the observations. The water is curved inwards in the beaker, and the water is raised in the tube, and the level is greater than the water level in the beaker. And in the second diagram you can see I have taken mercury. I told you I have taken mercury here, and the surface of mercury is curved upward, and this mercury also raised to the tube, raised into the narrow tube, glass tube, but the level in mercury level inside the tube is less than the level in that beaker. These observations you have to make here. This way, rising of water in a narrow tube is known as capillary rise, and the level of mercury in this tube is lower than this mercury in the beaker, and this depression of mercury in the tube is known as capillary depression. So the rise or depression of a liquid through the narrow tube is known as capillarity. So both together, the rise or depression of liquid through a narrow tube is known as capillarity. So this is another one of the important phenomenon related to fluid. So two phenomena together called capillarity, capillary rise and capillary depression. Capillary rise means the rise of liquid through a narrow tube, and the capillary depression is the depression of a liquid through in a narrow tube. These two together known as capillarity. Now let me explain the experiences which we mentioned previously. So first one, let me explain the chalk is blotted. The chalk is used to blot ink, isn't it? And how the ink can be blotted by using chalk. So you might have noticed in the chalk there are so many small pores, isn't it? And this pores in the chalk behaves like the narrow tube. That is capillary, we call it capillary tube. And this pores in the chalk behaves like this capillary tube. As the chalk dips in the ink and this ink raises through the pores in the chalk, and that is how the ink is blotted by using the chalk. That ink will absorb, that ink will be raised through this pores. So the ink can be blotted by the chalk. And the same reason is sweat can be wiped by using a cotton cloth. Okay, the cloth has small pores in it, and this can absorb the sweat, or this can be can raise the capillary raise takes place when this cotton cloth is dipped in the come in contact with the sweat. And the same reason is for dampness of the wall also. Wall has small pores in it, small holes in it. These pores act like a capillary tube, and when the water comes in contact with this capillary action takes place, capillary rise takes place, and the water rises into the through the pores. And this way, this is the answers for the experience which we mentioned previously. You might have noticed that small insects can walk on the surface of water or surface of river, surface of, isn't it? And ponds and all. And also you might have noticed that a blade, when kept on the surface of water, it floats. So the reason I will explain it is due to some other phenomenon which is known as surface tension. For that, I have to explain that. I have drawn a picture here. You can see some molecules of water I have drawn here. Molecules of water I have drawn here. You can see the surface molecules experiences different kinds of forces on it. That is, this molecule experiences the force of attraction from both the other molecules on both the sides, as well as it experiences a downward force also. And here it experiences the force due to the glass molecules here. Vessels, glass. If vessel is made of glass, glass molecules also attract this water molecule. So this water molecules experiences a force from different sides. So this surface will behave like a stretched membrane. That is, from all the sides it experiences force, isn't it? From both the side, and also the downward molecules also pull it downward direction. So this surface of liquid behaves like a stretched membrane, and this phenomenon is known as the surface tension. Okay, it is due to the force exerted on the surface, molecules on the surface from by the other molecules around it. So the surface behaves like a thin membrane, and this phenomenon is known as surface tension. It is due to the force of attraction between the molecules. This surface tension acts along the surface of the liquid, and it supports certain substances like razor blade to float on water, helps liquid drops to take a spherical shape, and also some creatures can walk through the surface of water due to this surface tension, which behaves like a membrane. Now I have explained the forces act on the molecules on the surface. That is, here some force acts downward due to the other water molecule itself. it attracts downwards, and the molecules of water on the surface experience force due to the other water molecules also here. And another force experienced or exerted on the molecules of water at the surface is due to the molecules of the vessel, the surface of the vessel, the molecules of the, here we can take it glass. So the molecules of the glass attract the molecules of water towards it, so that force also experience on the surface of molecules on the surface of water. So here two types of forces experienced is one, the same kind of particles attracts together to each other, and also different kinds of molecules attract. So the glass molecules and water molecules, attraction between glass molecule and water molecule. So two different types of forces exerted, and one force which is exerted by the same kind of particles is known as cohesive force. The attraction between same kind of particle is known as cohesive force, and the attractive force between different kind of particle is known as adhesive force. So two types of forces are cohesive force and adhesive force. Here for cohesive force example, molecules of water kept in a beaker, all the molecules of water itself attracts water molecules, and also in all the solids the molecules are tightly packed, and the attraction between these tightly packed molecules in solids is an example for cohesive force. Now adhesive force example, if we wet a paper and paste it on the wall, it stick with the wall. That is due to the adhesive force. The molecules of paper and the attraction between the molecules of paper and the molecules of wall. So different particles are attracted there. So we can we can stick the paper on the wall. And also when we count the nodes, we wet our fingers, and counting can be made easily, isn't it? So this way water molecule, the attractive force between water molecules and the nodes, molecules of the nodes, it takes place here. That also is an example for adhesive force. That is, we wet our fingers to count the note, is an example for adhesive force. And also when we dip a pencil in water and take it out, then the water molecules stick on the pencil. It is also due to the adhesive force. So these are the examples for cohesive force and adhesive force in our day-to-day life. So dear children, this much for today session, and we'll come to the next, we'll discuss more top points in the next session. So we revise once these all points, revise once again, and here we will meet in the next class. We will discuss more in the next session, and till then, bye.